Hello. To start this new version, if you have a previous one, the best that you have to do is to uninstall it, restart Blender, and then install the new one. To install the new one, you can just drag to the Blender and click OK. I want to because I already done that. So after installing the add-on, you can get the files, the portable files, and you have basically two versions. You got one with everything. It's about 26 gigabyte. You just have to unpack this folder and it will have all the three types of SAM and the GMX stuff. So you can use it with the add-on. But some places you can't get all in one due to limitations of the size. Then you will have to download these files and unpack all of them in the same folder. Then you can go back to the add-on and work in it. One more thing that I always have to point out is about the checkpoint. The file doesn't come with the checkpoints. You have to download it from the Hugging Face page, and you have to place the checkpoint. The easiest way is to place the checkpoints inside the same folder that the other files are in. You will have these files, these folders, not the checkpoints. So place the checkpoints here, create that folder, and send to the about dinner retreat folder. And you basically need those two files inside this path to the add-on recognize it automatically. Okay, so let's give it a try on what we have new here. So to start creating the animation, you have to select the folder where you have the Python. In this case, we are testing the SAM, so you have to point to this underline SAM Python, go inside of it and press accept. That's what you basically need to run it. And open the video sequencer. Let's select the video to put here. And then you have to set the destination folder. One big difference from V3 is that you have to set up an image folder and a PKL folder. From V4 and V5, you don't have to do that anymore. You just select the main folder and the add-on will automatically create and place the image files and the PKL files for you. And you can see if they are done here. You can see the amount of images, PKL, and the PKL with the SLAM update for the global placement. So let's select a folder to put this animation that you're going to create. And now we can generate the markers, render marker frames. It's done. Now we can select the SAM type that we want to use. In my case, I'm going to show you the difference between the three SAM. So first one, I'm going to start with the standard SAM 3D. That's the one we have since the version 1. And you can use this lens tracking. This lens tracking is better. It works better if you use from a moving camera. If it's a camera that doesn't move, it's not that useful. So as I'm trying to show the difference between the same options, I'm not going to use this lamp tracking. So let me put time watch here and let's run. You can also see the GPU memory usage and the RAM memory usage, so you can have a reference between them. I'll speed up the process. And see, it finished it in about 8 minutes, and it took about 15 gigabyte, 15.5 gigabytes of VRAM, and it went from 17 to 23 gigabytes of RAM. And this is, let me show the result. And this is the original. This is the result. Now let's test with FATSAM. Let's select a new folder. Render. And generate. Once again, I'll speed up the process. And with FastSend, you see that it took about 2 minutes to finish the same footage. It used about 8.6 gigabytes of VRAM and 22 gigabytes of RAM on my system. Okay. And now let's take a look on the SAM CPP. We create a new folder. Generate the frames. Select SAM CPP, reset, and run. Guess what? Speed up again. And SAM CPP did in about less than 1 minute. It took about 7 gigabytes of VRAM on my system and 18 gigabytes of RAM, considering that without using it, it was already with 16 gigabytes. So it was basically a difference of 2 more gigabytes of RAM. And it was using almost 4. It was basically 3 more gigabytes of VRAM. But one important thing that I must say about SenseCPP, it looks like it's fast as it's blazing fast, but I think it doesn't detect the hands. And you can test all of 3 to see that they got some difference between the animations. And let me show you the results. So I have the original loaded. Let me load a new character, which I'm gonna call Fast Sam, and I'm going to load the Fast Sam result. Let me play, and you see this yellow one is the Fast Sam. It's a little bit different from the original one. And now let's put the Sam CPP. Sam CPP. And okay, here is, you see that there's a difference between SAM CPP to the other ones. If you look on the front view, usually they don't make that much difference. But here are the options that you can use. Oh, okay. Just finished. Since we are here, let me show how it is the result from Gemax. So on Gemax, we have to select also the Python. And now select the video. And go. Let's check GemX with the default settings. Do I have to say what's going to happen? Okay, speed up. You see here with GemX using the default settings, it ran less than 2 minutes and used about 12 gigabytes, and my base usage of VRAM was almost 4, so 8. The 8 more gigabytes that it used. And on my VRAM was 24 using the GemX, and my base is about 15, so almost 10 gigabytes of RAM that it used. And let me load the animation. So let's try with the Onyx and Force PyTorch. Yeah, you know. You see, it ran in about it ran in 1 minute and 37 seconds, and the memory used top and almost 14 of VRAM and 25 of RAM, considering my system was already using 4 of VRAM and 14 of VRAM. So this is it, and hope you enjoy. Oh yeah, not only hope you enjoy, let me show the result from the two ways to run GemX. And you can see they are basically on top of each other, this one on the top, and it doesn't change much. So it's much more preference from you on what you're going to use. And from what I remember, not using Force PyTorch and Onyx, it was almost the same time. But okay, that's it. See you next time.